of isocyanates. So isocyanates general formula is RNC. Okay. So now isocyanates are unpleasant order, not pleasant, unpleasant order. But cyanates are pleasant order. Cyanates are pleasant order. Isocyanates are unpleasant order. So next one is volatility. Volatility means the substance or compound on strong heating it is converted into vapors. It is the nature of volatility. If the compound is not converted into vapor on strong heating, it is the non-volatile nature. So now the comparison of the volatility between cyanates and isocyanates. So now volatility of isocyanates is greater than cyanates. Volatility of isocyanates is greater than what is cyanates. So next one is actually isocyanates are insoluble in water but soluble in organic solvents. What is organic solvent? For example, benzene is an organic solvent. What is benzene? C6H6 is the organic solvent. So it is a non-polar solvent. Non-polar solvent. But water is the polar solvent. What is a polar solvent? So isocyanates are insoluble in water but soluble in organic solvents. But cyanates are soluble in water and also organic solvents. So next property is toxicity. Toxicity means it is poisonous nature. So now toxicity of the isocyanates is greater than cyanates. Toxicity of the isocyanates is greater than what is cyanates. So these are the physical properties of the isocyanates. So next one is chemical properties. What is chemical properties? So chemical properties of the isocyanates. First one is isocyanates are involved in acid hydrolysis. So actually H plus is the acid mineral. H plus is the acid mineral. H2O means hydrolysis. So what are isocyanates? Involved in acidification. What is acid acidification or acid hydrolysis? It gives primary amines. What is it? Gives primary amines. And HCOOH. What is acid? It is the formic acid. HCOOH is the formic acid. It is the formic acid. So for example, in the place of C alkyl, if you take methyl isocyanide CH3NC on hydrolysis. Hydrolysis means react with water in the presence of acid mineral. So then it gives CH3, it is NH2 plus HCOOH. What is HCOOH? So it is CH3. Okay, now it is H2. What is NH2? CH3 NH2. So now NH2, if you take 2 moles of, what is 2 moles of what is water? 2 moles of water. So then 2 hydrogens, 2 oxygens. 2 oxygens, 2 hydrogens and 1 carbon. It is the formic acid. So the obtained compound is methylamine, aminomethane. It is the aminomethane. So aminomethane is the one of the primary amine. So simply isocyanates involved in acid hydrolysis, it gives primary amines. So next second chemical property is isocyanates. What is isocyanates? Involved in reduction. So what is involved in reduction? So actually it is reduced to, isocyanates are reduced to secondary amines. So secondary amine means the amine group attached to another 2 carbons. Actually it is NH, it is CH3 first carbon, and alkyl must be contains carbon. So then one it is two carbons. Now it is a secondary amine. So this reaction undergoes in the presence of hydrogen, platinum, sodium, and ethyl alcohol, ethanol. So this reaction is reduction. It means simply isocyanates are reduced to secondary amines. Reduced to what is a secondary amines. So now, for example, if we take what is CH3NC, isocyanide. So it is reduced to CH3, it is NH, and it is a CH3. What is a CH3? CH3, okay, CH3, NH, CH3, NH, CH3, reduction. So now it is CH3, CH3, it is N. So now number of hydrogen 3 plus how many? It is 1 plus, it is 2, 4. So it means plus 2H2. What is it? 2H2. CH3, CH3. N, N. Number of hydrogens 3 plus 1, 4. So then 2 into 2, 4. Number of carbons 1. So now it is a secondary amine. Okay, secondary amine. So it is a dimethyl amine. So dimethyl amine. So isocyanates involve in reduction in the presence of sodium or ethyl alcohol or hydrogen and platinum. These are converted into secondary amines. So actually, cyanides involved in acid hydrolysis, it gives primary amines. Isocyanates involved in reduction, it gives secondary amines. So next one, third property is these two are the addition reactions. What are these two? Are the addition reactions. So then isocyanide, addition with, it means react with, addition with chlorine and sulfur. Chlorine and sulfur. It gives what is RnCCl2 or RnCS type of isocyanates. What is it? Gives Rn type of isocyanates. So now, for example, it is explained with one suitable example. It is explained with one suitable example. So for example, it is alkyl group. Okay, R is alkyl group. For example, it take what is CH3, CH2 ethyl, and it is isocyanate, ethyl isocyanate plus chlorine addition reaction plus Cl2, then it gives what is CH3, CH2, single bond N, double bond C, Cl2. What is C, Cl2. So now it is a secondary amine. Secondary amine with isocyanate. It is ethyl. It is the ethyl isocyanate. Ethyl isocyanate. It is the ethyl isocyanide. Ethyl isocyanide addition with chlorine, it gives ethyl isocyanide. So now 1, 2. It is CH3, CH2, CH3, CH2. It is N, it is C, it is Cl2. So now same as wherein isocyanide addition with sulfur. Addition with sulfur. So now, for example, so then CH3. What is the CH3? It is NC, methyl isocyanide. It is treated with 1/8 moles of S8. So it is the polymolecular compound. So now it gives what is R, it is N, okay, it is R, N, double bond C, double bond S. So then, wherein for example, in the place of alkyl group, if you take methyl, CH3, it is N, it is C. So 1/8 into S8 means 8 cancel, number of sulfurs, what is 1. So now it is the methyl isocyanate. So it is the methyl isocyanate. NCS, it is isocyanate. SCN, thiocyanate. NCS, isocyanate. It is a thiocyanate. It is the isocyanate. Isocyanate. So next one, as well as isocyanates react with mercuric oxide, mercury, HgO. What is a mercury oxide? So then it gives corresponding what is isocyanates and HgO2. For example, let us consider methyl isocyanide. Methyl isocyanide plus 2 moles of HgO. 2 moles of HgO. So then it gives CH3. It is N double bond C double bond O plus Hg2O. What is a Hg2O? So next one is fourth reaction. What is fourth reaction? Isocyanates prolonged heating. What is isocyanates are prolonged heating. Isocyanates are converted into cyanates. Isocyanates are converted into cyanates. For example, CH3 CH2NC. It is ethyl isocyanate. Ethyl isocyanate prolonged heating. So prolonged heating means continuous heating. So time taken more for the heating. So then CH3 CH2NC. So now the obtained compound is CH3 CH2. It is a CN. So CN means what is a C triple bond N. C triple bond N. So wherein NC means N triple bond C. Wherein nitrogen attached to carbon, but carbon attached to what is a nitrogen. It is a cyanide, isocyanate, it is a cyanide. So prolonged heating of the isocyanates, these are converted into cyanates.